today's topic, today's stream. Well, I don't know if anybody's been following Stuart's streams, but in his last stream he was trying to simulate acceleration and momentum for his plane, and he was having Stuart's streams are the best. yeah, they are. Especially when you shouted at the screen. Does CPS dark mode? I don't know. I don't know. I haven't seen the latest one yet. Who's Stuart? So he was struggling with simulating acceleration and momentum. So I thought I would do. Do you have a new camera light? It seems to give off a lot of light. What, you mean that one? It's on. Yeah, the natural light LEDs have gone. So now I'm on cool white. So I'm now. So it's mega white. Hang on. If it's too bright, let's turn it down. Whoops. Let's see if we can turn it down. There you go. There you go. Ghost John. Yeah, the warm white LEDs have gone on it. It flickers all the time. I noticed that on the last stream. Anyway, so this is another Twitch lesson. Lesson number 15. So we do, every now and then we do a Twitch lesson, yeah? And so what I'm going to do is, I'm doing it in CPS, right? Because what I want to do is write it in BASIC first, yeah? Write it in BASIC first and then convert it to machine code. So you can understand how acceleration and momentum, how acceleration and deceleration, or momentum for another word, works. Because Stuart's having concept issues, call it a concept issue, of how to try and do it. So I thought we'd do it. We'd do it in BASIC and then we'd migrate it to machine code. And so all we're going to do is put a square on the screen, square sprite on the screen, and we're just going to get it to slowly take off and gain speed while we've got a finger on. When we take the finger off, it slows down, so it doesn't do straight away. Yeah. So hopefully Stuart might find this interesting and then be able to put the concept into his new bomber game. Oh, by the way, just in case you want one. Also, I have added a new item. Or two new items. Here we go. Self-promotion. You can't beat it. There we go. They haven't got a beer glass or wine glass. They don't do it. So I've done the next best thing. You could buy the coffee flask, as we do, a vacuum bottle with Nico's Run or OSK on it. The new items that have just gone into the merch store. So if you want a Nico's Run flask or vacuum bottle, there you go. Or if you want me with just my OSK on it, yeah, go grab. I'm not making any money on them, by the way. So that's how much it would cost if I bought them, yeah? So I'm not making any money. It's just basically for you guys. If you want a memento, there you go. But yes, the Nico's Run Black Flask does look nice. Does look nice. I'm not too sure about the blue one. The white one looks okay, but the black one does look smart. OSKstore.com. Your beanie cap still works. Good. I've got one now. It's up there. So just in case you wanted something with Nico's run on it and you didn't want a t-shirt that's functional, there you go. You can put your coffee in it and enjoy Nico's run while you're having a drink. It's starting to fall apart. Really? God, that's not good. What, this one? Oh, you had the special edition plank one, didn't you? Yeah, you had the special edition plank one. Anyway, the stretch is gone. Oh dear. Anyway, just in case you want to buy one, knock yourself out. I did it because Stackbats. You might get the OSK fart mask. But Stackbats asked for a beer glass with Nico's run or wine glass, but they don't do them. So there you go, Stackbats. If you want to put a coffee in one, be my guest. I know it's a shame they didn't have them. Didn't have them, mate. Right. So, let's get started, shall we? So, we need to create a sprite. So, line 10 for I equals 0 to 63. Poke 192 star 64 plus I, comma 255. Next I. Right, that should fill our sprite. That should fill our sprite as a block. So poke. Oh, it's all in decimal, in it. 2040, comma 192. So that sets up the pointer. Poke 54727. Oh, I'm gonna have to get the Bible out. Oh, I wasn't that far away. Five, 3, 2, 4, 8, and 5, 3, 2, 4, 9. Yep, 9. Yeah, that should do it. Let's put that to one side so I can see it. The plank one. And tourists, especially the people from the UK, look at you strangely. Basic in lowercase is just wrong. Yes, it is a little bit, isn't it? Right. Oops. Let's just see if we get a square on the screen. No. What have I missed? Oh, colour. Maybe we need a colour. Da, 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 da. 53288. Right. 2040 with 192. That's right. Yeah, 2040 is right. MSB for... Oh. Yeah. We'll set that to 0 just in case. Just basic. Just basic. Nothing spectacular. Just enough to get Stuart. Get his juices flowing again. Right, so that's the most significant bit. Right, let's see if the sprite's on the screen, which it's not. I am doing the right one, aren't I? That's right. Oh, yeah, yeah. Ah, plank. Dope. There's always something you miss, isn't there? 53269. Oh, it's just past press F6 then. There we go. $50 points. I'll be generous. I'll give you 20. There you go. But it's white. It's not black. Have I got the right colour? $2.7. No. Right, it's F5 in here, I think. Right, there's the go. There's the sprite. Here we go. So we got the sprite on the screen. So the way to simulate, the way to quickly, simply simulate acceleration. Acceleration is like, you know, we're going to apply a force to that block when we've got the key pressed, and the longer we keep the key pressed, the force is applied again, which then gives you your acceleration, which then you add to the velocity. So we're going to have some variables, and they are going to be v equals sprite velocity. And let's just make that sure that's on a tab. Then we're going to have A is equal to acceleration. So minus A is going to be like drag. Yeah, we're going to make acceleration and drag the same. We're not going to differentiate between. I mean, we could do it, but I can't see the point. And what else do we need? So we're going to apply the acceleration to the velocity to simulate it. Yeah, that should be it. Right, so 40. So we're going to say A, acceleration, is going to equal 0.25 pixels. Yeah, so it's going to equal 0.25 friction. Yes, yeah, we could do that. Yeah, F is friction. Right, so first things first then. Right, so we'll set friction. So friction is going to be now we'll set acceleration is 0.25 and we'll make friction equal to acceleration. Yeah, we'll make friction equal. Oh, I've got to use little letters. Right, friction is equal to acceleration. So when we let go, we will decelerate at the same velocity as at the same rate as we accelerate. Yeah. And then we'll set velocity is equal to 0. So that's where we're starting. Yeah. So we are going to read the keys. So we will go K is equal to peak 197. If K equals 64, and velocity equals 0. Oh no, if velocity is less than 0, then V, in fact, we'll do that. V equals 0, go to 50. So that is saying if no key's pressed and our velocity is less than 0, equal or less than 0, we're going to make it 0, and then we'll go back and read the key again. Right, so I need my website. Hang on, I need my website. So I've got the key codes. There we go. Right, so we are going to, we're just gonna make it accelerate and decelerate to start with. So we're going to use a space bar, so it's 60. Yeah. So if K equals 60, then velocity equals velocity plus acceleration. And then we'll go to 200. Right. So now, in fact, I'll make that 80 and we'll stick another one in there. If K is equal to 64 and velocity is greater than 0, then velocity equals velocity minus friction. Right, so I've just thought of something else. Right, so we need X equals 80, Y equals 80. So there are X and Y. Alright. So 200. Go to 50. So that goes back round. Right, 200. This is where we're going to mess around with, we're going to apply the velocity to X. So X equals X plus velocity. Just so we're not messing around with MSB, we're going to do X equals X and 255. That'll make sure that we don't have to mess around with the most significant bit. And then we'll do poke 53248, comma X. Right, let's see what damage I've done. So we shouldn't move until I hit the space bar. There we go. And the longer I hold it, the faster it gets. And then when I let go, it should slow down. There you go. Right, so we know that acceleration has to overcome friction, you've got to apply more acceleration. So let's say let's say if we take the friction out now and say we'll specify friction. That was a quick stream, yeah. Well, it's, I mean, once you understand the mechanics for it, it's not so bad. So if you want to do it properly, then we have to overcome friction. So if we say friction is 0.5, yeah, then acceleration has to be friction times by, say, 2, yeah. So if we do that, we should accelerate a lot quicker, yeah, than if we go, well, yeah, I suppose we could do go sub, but once we've applied the velocity, we don't need to go back to it. We just go back to 50, yeah. So here, when we are applying friction and stuff like that, we can then do it here, yeah. So it's acceleration minus friction. Right, so essentially we should be accelerating at the same rate as we slow down. You know, we haven't applied any hard code into it at all. Right, here we go, bang. So off we go, and then let go, and it slows down. Now we could say that friction is really bad. So let's say well, we'll say 5, right? Let's say we're in sludge. F5. Right, here we go. Away we go, and then boom. But we could always say that, you know, that acceleration is not 2 times friction. It's like 1.1. Yeah. So acceleration is only just better than friction. That means we should be able to accelerate slowly. There we go. And then decelerate fast. Yeah. So friction is way too much there. So we'll change it down to that. Whoops. I pressed F6, F5. So here we go. Hit the space bar, slowly accelerate, then let go, and it stops pretty quick. Pretty quick. Now, if we do friction at 1 pixel, and we'll just give it a bit more acceleration, we should get some sort of reality, I think. Here we go. Slowly, catchy monkey. There we go. Oh, we even get bounce back. We just get that little bounce back. So, in terms of how a Stuart would do it, this is the more complicated way, yeah, because we're saying that friction is always applied to the velocity, yeah. But you could just say, no, we're not going to apply the velocity to it. We're just going to say acceleration is. We only use acceleration to do it, yeah, and we use friction to slow it down. So when we run it again, right, here we go. There you go. So acceleration and friction are almost the same. And the reason I say almost the same is because at acceleration is 1.2 times the friction. If we made this 2, you'll find out we will accelerate faster than we slow down. Yeah. Here we go. See? So that's acceleration and momentum in a nutshell. So when Stuart's doing his working out, that's what we need to do. Now, we're not taking any consideration of gravity and therefore thrust. This is not Neptune Lander. We did all that in Neptune Lander. But what I wanted to do was be able to give Stuart an idea of what he needs to do when he wants to apply this framework to his game. And I'm only calling it a framework because I'm hoping that he'll take what's here and then apply it to his own game in his own style. Yeah. So let's just make sure I've got the numbers right before we go to the machine, before we try and code it in machine code. So spacebar, spacebar, spacebar. Yeah, I think that'll work. So 1.2. Right. Binary fractions. Let me go. So 1 over 2. 1 over 4. Cool. What's 1.2? It's going to be a quarter, isn't it? It's going to be that. So if I do that, that's a quarter. 1 1/4. 1 1/5. Yeah, but it's very difficult to represent a fifth in binary. Yeah, because 1.25 is equal to 1 and 1 1/4, which is equal to 1, 2, 3, 4, 5, 6, 7, 1 and 0, 1, 1, 2, 3, 4, 5, 6. That's a quarter in binary. So that what you see there, binary, is 1 1/4. Right, so we should... it's harder working, yeah. Well, I mean, 1.2, you can do it. You've just got to divide it by 2 and just take the remainder. So 1.2 will be probably another value down here, switching on. Because that's... So that'll be 0 and then it'll be 1... Probably 1, 1, 1, 0, something like that. That's how you would work out 1.2. Divide by 2, take the remainder. Because it's basically 5, isn't it? It's basically 5. But we'll leave it at 1.25 because it makes life easier for us. Yeah. So, am I going to write this in CPS, in machine code, or am I going to use Kick? Let's save it first. We'll use Kick. So I need to... Twitch streams. Right. Acceleration. Right. Okay. So, Hang on, I'm just going to grab the workspace to make it so you guys can see it. I'm going to nick Nico's run workspace. Where are you? Paste that in there. Right, so let's open the workspace. There you go, you can see it now.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Who's that? Tron, 7 months. My, thank you for subscribing, mate. For 7 months as well. Oh, it's a long time, long time. Welcome anyway, welcome. Who else have we got in chat? We've got 21 viewers. What's going on? 21 viewers. Who else is in here? Whoever's in chat, say hello. Let's see who you are. Don't be shy. Right, so let's get started. Right, basic, upstart, start. Right. So, start equals need a calculator.
Hi, John here. Another subscriber. Stay a while. Stay forever.
What's going? Docster.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Oh dear. You can't blame Nico. He's lying in his bed.
Hi, John here. Another subscriber.
You can't blame
Stay
Nico
a while.
for that. He's
Stay
lying in his
forever.
bed. Hazemaker's got a sub.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Oh dear. Is Hayes on?
Hi, John here. Another subscriber.
Oh, Andy's got a subscription as well.
Stay forever.
Is Hayes on? Does it give people that are actually watching them, or is it just pick them at random? Oh, you don't have to be in chat to get a sub. Okay. Oh, I see. Oh, I didn't know that. Well, Docster, thank you very much, mate, on your personal quest to try and get my, get my subscribership up. Much appreciated. And you know I don't expect it because I don't. Right. I need to work out some numbers. So 192 times 64 is equal to 3000. So dot fill. It's length first, isn't it? Yeah. Fill 64 with 255. So let's create some variables. So velocity low equal dot byte 0, velocity fraction, because we're going to be talking fractions. Oh, you can give sub to channels. whether you're streaming or not. Right, okay. Didn't know that either. Did not know that either. Okay, what are you complaining about? Oh, I see. I see. Right. So that's velocity. Now, acceleration, we know what that's going to be, but we'll set it anyway. So this is going to be byte 1. And the acceleration fraction is going to be byte, and we'll do it in binary for 1, 2, 3, 4. Oh, OCD's kicking in. Friction, low. We're only talking that. And friction frac, because we need to keep the same philosophy going. What's going on? Beja. You're too tight. Okay, mate. Right, what else have we got? So, what else did we have here? So, we've got velocity, acceleration, and friction. X. We need X low. We'll default that to 80. X frac. And we'll default that to 0. Right, so they're the main players. They're the main players. Right, so we need to set it up. Okay, so LDA hash 80, hash 192. Store it in 07F8. LDA hash black. Store it in DO2B, I think. No, DO27. Stores black. LDA X low. Store it in D1000. LDA, well, and then load hash and store it in, what is it? Don't know it off by heart. I think it's 16? 15. 15. Right, so that should turn the sprite on. That should turn the sprite on. So we've set the pointer, we've said it's black, we've set the location, and we switched it on. Right, let's see if it does it. We'll put an RTS in there as well. There we go. Right. So let's tag all this lot. Right. Right, so, oh, we need K. We'll say key, we'll call it key. Right, so looper, here's our looper. So this is our looper for 10. Right, so let's get rid of that. And we'll, can I scroll that up? No. So we'll get rid of the file and we'll move it over there a bit. So we can see what we're doing. So we've already set the values to the right thing. So that should be 1.25. That's 1. That's 80, and then the key. So first thing we need to do is we need to load 197. Right. And then compare it with 64. Branch if not equal to, and we'll say test space bar. Oh no, test no. Oh no. Test space bar. Because now we can test the velocity. So if we load velocity low and branch if minus, that means we've gone too far, yeah, which will be this one here. So if we go branch plus to no, yeah, branch plus to apply friction. There we go. Now, why are you not happy about that? Oh. Right, so here we are below 0. So what we're going to do is we're going to load 0 and we're going to store it in vlow and vfrac. Yeah. And then we set it back, get it back to go to looper. So what we're going to do is so we can cross refer this lot, we are going to do this, right, for the beginners. So this is line 20. So line 20, let's do line 20 properly. And setting the colour. Right, so that's line 20. Line 21. Oh, we've got to set the MSB, haven't we? So line 30. Ooh, that's 0 anyway, so we can just store it, can't we? Store it in DO10. That sets the most significant. And then turn it
Hello,
on.
John here. Thank you for following. Hope you enjoy the stream.
Who's followed? Say hello, who's followed? Don't be afraid, say hello. Welcome. Welcome, welcome. It's 0 unless we change the colour. Yeah, I know. But we'll leave it as... Alright, just because you're being picky, just in case. We'll do that. Right, so that's line 30. So let's make sure... So line 40 is the defaults, yeah? So we'll put a little comment in here saying line 40 already defaulted variable storage. Yeah. So this is line 50. Oh, I like having the camera there. I don't have to break my neck turning around to see what they're doing. I think it's Zelcade. Welcome. Welcome. You've just in time to join the madhouse. Right, so this is line 50. Then this will be line 60. And this here is line 60. So that's line 60 there. And line 60 to there. Right. So apply friction is line 70. Right. So we've tested for the whether there's no key. And if the velocity is less than 0, we've set it to 0. But if it's greater than 0, then we need to subtract the friction from velocity. So, right, so here we go. In fact, I'm just wondering if I should paste the lines in. Yeah, let's do that. Just to help the guys out, the newbies. Oh, you're talking directly to the CIA, mate. Yeah, remember, this is all for beginner stuff. So we try. I know what you're saying, but remember, this is just talking to the beginner. Yeah, the beginner. So they will look at 197. Yeah, yeah. They won't know about getting rid of basic or getting rid of the kernel. Yeah, we're just doing just for the beginner. Yeah. But I know what you're saying. I know what you're saying. We would do that. Us professionals would do that. Right, so line 60 is this. Right, so line 70 is this. But because we're doing it in machine code, we don't have to do the retest for the K. Yeah. We can just do straight away. It's like an else. Yeah. It's like an else. So here we are going to do the subtraction. So set the carry. LDA. Let's see. Night, Gary. Talk to you later. Velo. Subtract. No, it's not Velo. It's VFrac. Then subtract. Oh, it's friction. Friction frac. Store it in VFrac. LDA Velo. Subtract 0, store it in VLow. That's doing this minus F, and then we are jumping back to looper, which is line 50. Alright, so now we're testing for the spacebar. So this is line 80. So this is this. Right, so we have to do the same thing. So we've just jumped. So remember, we've compared it with 64 and we're jumping straight out. So the accumulator still has the key value. Yeah. So compare it with 60, which is the space bar. And branch if not equal to, and we're going back to looper. If it's not equal to 60, we're going back to looper. So, if it is equal to 60, this is now... Oh, Aston and his shakes. Makes me jump. Right. So now we're going to add the acceleration to velocity. So clear LDA V frac. ADC acceleration fraction. Store it in V frac. Then LDA V low. ADC acceleration low, store it in X low. Right, then we are jumping to 200, but we don't need to because we've done that here. So this is line 90, right? That's line 90. This is the 30-minute warning. Nah, see, FaZe, see, you twigged. Ah, I was trying to get away with it. I was trying to get away with it and using Stuart as the excuse. Never mind, never mind. You've twigged. Right. So, that's line 50, which is going back to the looper. So then we apply the see in a bit, Saucy. So we apply the acceleration to the velocity. So this is now line 200. And line 200 is this. Right, so we are going to add the velocity. Nico Taxi. I haven't decided if I'm doing it yet, mate, to be honest. I haven't decided yet. Aston's up. Aston's up. Right, so we're going to add the velocity to X. So LDA X frac. Add velocity frac. Store it X frac. LDA X low. ADC. Has he gone downstairs? Oh yeah. V low. Store it in X low. So that's doing that. Now, we don't have to apply the 255 because we're only messing around with the low value, yeah? So we don't have to do that. So we're implying that. We imply it. Right, so line 210. So we'll copy that. Contemplate on the living room carpet. I hope not. It sounds like he's having a drink. It sounds like he's having a drink. Right, so we're going to look. Now, I know the accumulator has got X low, but we're going to load it anyway, just in case. And then we'll store it in the sprite, which is D000. That's the X value of the sprite. And then jump looper. So we don't need that. So this is line 220. Right. That should be it. Right, that should be it. Right, let's see if we...
Hello, John here. Thank you for following. Hope you enjoy the stream.
Who's followed? Say hello. Who's followed? Say hello. Don't be scared. Don't be scared. Ooh. Schwarzfar Child Planet. Welcome. I hope I haven't destroyed your name. I do apologise if I have. Welcome. Will be quite aggressive acceleration. Yes, it is. Yes.
Hello, John here. Thank you for
what's
following.
Going on? Who's following?
Hope you enjoy the stream.
Who's following? Say hello, followers. So we know who you are. Welcome, said Who 13. Welcome. Welcome. Yes, yes, you are quite right there. You are quite right there. We ought to put a raster test in here, haven't we? So LDA 200. Compare it. Let's do the raster test. Raster. Anybody know what the raster number is off by heart? It's early on, isn't it? DO12, thank you. Oh, I'm not bothered about. We're not bothered about. We're not bothered. We're not bothered about optimization at the moment. Right. That. Let's see. Let's see. So we're moving a pixel every loop. Ooh, that is going to be some serious acceleration. We'll try it. That's gonna be fast. Right. So we should be still. Right. Press the space bar. Boink. And of course, we've screwed it. Screwed it. What is wrong? Oh, it's because of the acceleration going off the planet, isn't it? Right. Let's do something about this. So we're going to divide 1.25 by 60. No. 1.25 by every quarter of a second. That's it. Every 15. Where's the calculator? So we want to move 1.25 every quarter of a second. So we're going to have to divide that by 15 to give us the interval. 0.833333. Right, okay. Where's spreadsheet? Spreadsheet. I can't remember if I saved it, which I didn't probably. So, equals 1.25 divided by 15. There we go. Now, if my memory serves me correct, we divide by, or we times by 2. Do we times by 2? Oh, I can't remember. Can't remember. Where's Hunchback? Have I still got the spreadsheet in Hunchback? Not Hunchback. Neptune Lander. Where's Neptune Lander? Here's a spreadsheet in there. No! Are you joking, John? I didn't have a spreadsheet in there. I did talk about it. I think you have to times it by 2. I think you have to times it by 2. I can't remember. Oh, disaster. Where's my stuff? Where's my stuff? Let's put it over there. Retro. Oh, epic fail. Where's the retro stuff? Okay. I'm trying to remember how we convert that into a binary number. I'm sure it's times by 2. So that's a 0. Zero, 0. That's a 1. Zero, 1. Zero. So it's going to be repeating, isn't it now? So that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Right. That could be our binary number. I am sure it's that. So this is going to be right. So let's do this. That's what it used to be. That's what it is now. That's what it used to be. .byte. And this is what it is now. So it's 00010 So 1 divided by 15. .66666. So we do the same thing again. So we'll grab that, knock it down like that. So that's 0, 0, 0, right, 1. And that looks like it's repeating it again. 0, 0, 0, 1. Because if I take 1 off that, yeah, it repeats again. Right. Okay. So that means the friction is going to be before dot byte 0, that's before, and then after it's going to be 1 2 3 1 1 2 3 1. Right. Right, let's see. Do we get a bit more steady acceleration here? No. So something is going on. So let's see what's going on. Right, F6. Right, I'm going to stop that because I want it there. Right, I'll restart it. So, space. Oh. It's not even doing it. It's not even getting here. But it should be, because that's moving. Stack pointer's alright. The breakpoint doesn't seem to work anymore. I don't know why the breakpoints don't seem to work. Okay, let's put a breakpoint there. Right, now it's breaking. Okay. So this should be saying branch if plus, subtract, go back. This should be now minus. So load, that's FF, and it puts it back to 0. Right, so let's put a breakpoint there. Get rid of that one. Right. Load 0, add that, store it. Load that, add that, store it. Load that, add that, store it. So it shouldn't have moved, and it hasn't. Right. But that's disappeared. Oh, it's a... Hang on a sec. Put a breakpoint there. I want to see what number it's getting out. Not there. There. Right then. Space. So we are loading 0. Why are we loading 0? X is already set, so why are we loading 0? L, oh, hang on. X low is 80. So why is it loading 0? Right. Oh, here, that's why. That's why. Yeah, Control Shift F5. Right, hopefully. There we go. Now it's just stopping. So why is it just stopping? So when we're doing the deceleration, which is here, apply friction. Ah, apply friction. Go to 200, and we're not going to 200. Right, 200's here. $200 here. So let's put that jump in. So sit. Hello Magna, welcome. First time chatter, welcome. Right, let's try this now. So we should have some sort of acceleration going on. And then it should slow down. And it's going backwards, look. It's going backwards. What on earth doing? Why is that going backwards? That is going backwards because I bet it's this. Right. Branch shift minus. If it's minus to looper. To no. To here. Right, let's try that. Right, here we go. Then let go. It slows down and stops. There we go. There we go. So simple. Simple acceleration and friction. So hopefully when Stuart watches this, if he's not already online, he'll be able to apply this to his game. I'm just wondering. We'll put some tests in it. Yeah? Right, that's what that does. Position. Look at me writing comments. Look at me writing comments, eh? I can't spell. That's not position. That's not how you spell. Position. There we go. What a... Right, so... What we doing? What's... Oh, you're making an you're making a similar routine for example, but for an up scroller. Well, the philosophy is the same. The philosophy is the same. It's just you're applying it to the scrolling value rather than the sprite itself. So much friction, it was negative. Oh, doing some demo stuff. Nice. Now, stop being meowish. Stop being meowish. Dear. Oh dear. Right, okay, any more comments? Right, here we go. So this is... velocity. That's applying acceleration to velocity, and this is applying the velocity to the X position, and that's it. Right, so we have two ways of doing this. Alright, so this is using machine code and stalling it using the raster to drop it down to 50 frames a second, alright? And we've then also got a basic version that does exactly the same thing, but in basic. Yeah. But it's running a bit quicker because we haven't got any delay in there. Alright, so that is a little demonstration on how you can apply acceleration and friction to a object on the screen and control it. Right, that was my timer warning me. I've got to do Nico's eyes in 3 minutes. Alright, right, so what time it is. Right, let's... Any questions before we move on? Is everybody alright? I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.